leaf plots. Let's take a look at this example. The taste test reported in 2 consumer magazines, 35 chocolate chip cookies were rated according to flavor, freshness, and texture. For the 27 cookies that were rated good, very good, or excellent, the cost per 30-gram serving is shown below. And these are the cost for all the 27 cookies, okay, ranging from 10 cents, okay, listed down all the way down here to 12 cents. If you're asked to organize this set of data and present it in an easy to read format, you could construct a stem and leaf plot. So how do we create a stem and leaf plot for this type of data that we have? Okay. First and foremost, in a stem and leaf plot, the greatest place value common to all the data values is usually used for the stems. Again, okay, the greatest place value common to all the data values is what we use for the stems. Okay, the next greatest place value forms the leaves. So after we get the greatest place value, the next greatest place value will form our leaves. Okay, so follow these steps to construct a stem and leaf plot from the data above, from the data we just had. First, find the least and greatest price. The least price is 10 cents and the greatest price is 58 cents. Okay, so after we find our LV and our GV, okay, we take note of it. The least price is 10 cents and the greatest price is 58 cents. LV stands for least value, GV stands for greatest value. From there we move on, we find the stems. Okay, if the least price is 10 cents, okay, this means that it has 1 in the tens place, the number 1. The greatest price is 58 cents. It has 5 in the 10 cents. Sorry, it has 5 in the tens place. Draw a vertical line, like so, and write the digits in tens place from 1 to 5 to the left of the line. 1, 2, 3, 4, 5. Okay, some stem and leaf plots, you can write the stems as 5, 4, 3, 2, 1. Okay, in this case, we write it as 1, 2, 3, 4, 5. If you notice, okay, we did not find out if there are leaves for 2, 3, 4, and 5. Okay, if you find the least place value, which is the 1, and the greatest place value, which is the 5, you need to include all the place values in between 2, 3, 4, and 5, irregardless if there are stems, or sorry, if there are leaves for these stems or not. Okay, step number 3, after that we simply start listing all of the pieces of data. Record each of the prices in the plot by pairing the unit digits or leaf with the corresponding stem. For example, 10 is plotted by placing the units digit 0 to the right of the stem. Okay, this is more understood if you have the data, and this is the data that we have in the previous page. I just copied it, so for your own purposes, copy it also on a piece of paper if you ever encounter this type of problem again. Then this is what you do. The first one is 10 cents and the tens place value is 1, the ones place value is 0, so that the 1 is your stem and the 0 is your leaf right here. Okay, so after that you cross it out and then you move on to the next. 11 cents, okay, you get the 1 and write it there. Okay, 58 cents, and then after that you cross it out. 58 cents, okay, 5 is your stem, 8 is your leaf. Okay, so write it next to 5 and 8, you cross it out. Okay, so if you notice, let me cross it out here, you continue to cross out your data that you have. Of course, you don't cross it out in the book, that would be sacrilegious, so you need to write this down on a piece of paper and then cross it out from there. So again, we have another 10 cents, okay, and that's how you got that 0 right over there. 25 cents, you cross that out, and that's how you got that 5. 49 cents, you cross that out, and that's how you got the 9 next to the stem. Okay, and the procedure continues until you reach 12, until you've crossed out everything, which is 12, which is that one right over there. Okay, so that is the next step. You need to put the leaves next to the stems. Next step, step number 4, rearrange the leaves so that they are in order from least to greatest. After you have created your stem and leaf plot, if you notice, the numbers here are not in order from least to greatest. To better organize your set of data, you need to be able to organize them from least, the leaves from least to greatest, and this is what you do. So you basically get these set of numbers right here, okay? You get that set of numbers and organize them from least to greatest right here, okay? And that's all you do. Organize them from least to greatest. You get that set of data, okay? And then step number 5, include an explanation or key of the data. Now, if you notice, this is just a bunch of numbers. If you do not include an explanation or a key, this would not mean anything. So what you want to do is include a key, which simply means this. If you include a key, all you need to do is get one piece of data, in this case 13, okay? So you get the 1 and the 3 and include that there. 1 vertical line 3 means 13 cents. You are basically looking at these two numbers right here. Okay? Can I use 1 vertical line 0? Yes, I can. I can also use 1 vertical line 0 if I want. Okay, which means 10 cents. Okay, let's do 2 so it won't do that again. So I can do that too, which means 12 cents, and so on and so forth. I can do 5 vertical line 8, which means 58 cents. Okay. Alrighty. Which means 58 cents. That should be there. So I can do this too. I can do 4 vertical line 6, which means 46 cents. Doesn't really matter what piece of data you use, for as long as you have the key. That makes it this makes this set of data easy to understand, because now you have a key. You know that this is all these numbers are in cents. Okay, and finally, it is easy to see that nearly all of the prices are between 10 and 29 cents because those rows have the most leaves. Okay, so if you look at this set of data and you organize them, you notice that most of the prices will fall between 10 cents and 29 cents. Okay. Okay, next. So take a look at this example. Hold on. In the last 10 games for the 1995 men's professional basketball playoffs, the points scored by Akeem Olajuwon were 27, 41, 43, 20, 42, 39, 31, 34, 31, and 35 points. We want to make a stem and leaf plot of this data. Okay. First and foremost, the stems are 2, 3, and 4 because the first thing that we need to do is look for the least number and the greatest number. In this case, the least number is 20 points. That's the least he scored during that particular season, and the greatest number of points he scored during the 1995 playoff is 41. Okay, and that's why your stems are 2, 3, and 4. Get the least and the greatest, and simply include the numbers in between. Okay. After that, we create a vertical line and put the leaves down and simply start writing down the leaves for the stems. So 20 points is there, 27 points is there, 31 points is there, another 31 points because there are 2 games where he scored 31 points, 34 points, 35, 39, 41 points, 42, and 43. I'm sorry, he did not score 41 points. He scored 43 points. So the greatest value is 43. Okay, so the greatest number of points he scored during that time was 43 points. The least was 20. Okay, so it's saying in which interval do most of the points scored occur. Okay, remember that each stem represents an interval. For example, the 2 stem represents interval from 20 to 29. The 3 stem represents the interval 30 to 39. And the 4 stem represents 40 to 49. Those are intervals. Okay? So, now we can answer that question. In which interval do most of the points scored occur? It happened during the 30 to 39 point interval. Okay? And that is our answer. Olajuwon scored in a 30 to 39 point interval more times than in any other intervals. Okay? So that's a good example. A back-to-back stem and leaf plot is used to compare 2 sets of data. In this type of stem and leaf plot, the leaves for one set of data are on one side of the stem, and the leaves for the other set of data are on the other side of the stem. 2 keys of the data are needed. So this is just a regular stem and leaf plot, but you have to create it back to back. So in order to create this, okay, the stem needs to be in the middle of your stem and leaf plot. Okay, how do we do this? Let's take a look at this example. A nutritional analysis was done for several fast food restaurants. The amount of fat in grams of their burgers and chicken is shown below. So you have 2 sets of data, the amount of fat in grams for burgers and chicken. This calls for a back-to-back stem and leaf plot. And these are the data that you have. Okay, and from there, first we find the least and greatest the least and the value and the greatest value of each set of data. Okay, in our case of burgers, the least value, let me make this correct now, is 10 grams of fat, and the greatest value is 36 grams of fat. For the chicken, the least value is 9, and the greatest value is 20. Okay, so the burgers will have a stem from 1 to 3. The chicken will have a stem from 0 to 2. Why 0? Because the tens place value of the chicken is 0. So if you notice, the least value would be 0, and the greatest value would be 3 in the tens place digit. And that's where your stems will come from. Okay? Get the least place value, which is 0, the greatest place value, which is 3, and that's the reason why you have your stems from 0 to 3. 0, 1, 2, 3 will be your stems. Okay? And then we create our back-to-back stem leaf plot, burgers and chicken. Okay? You have the chicken as 9 grams of fat, which is the least value. List all the grams of fat on the burgers and the chicken, and arrange them from least to greatest, if you like what you have here. Okay. After that, create a key. 6 vertical line 3 indicates 36. 2 vertical line 0 indicates 20. Okay. So that's how you create your back-to-back stem and leaf plot. Now we can answer this question. If a lower amount of fat is better, which type of fast food is better? If you look at this stem and leaf plot, you'll notice that in the interval of 10 to 19 grams of fat, chicken has more numbers in it, more data in it. What does that mean? It simply means that at that particular interval, chicken is better because it has few amounts in the 20 to 39 range than the burgers. So the 20 to 39 range, chicken has only 1 piece of data, where the burgers will have 5 pieces of data. Okay? Because most of the piece of data will fall in the 10 to 19 interval range, which is a lot lower than what the burgers have. Okay? So this is how you interpret your stem and leaf plot. Okay? And I think that's it. That's it. Okay, so on Google Forms, type a summary of what you've learned by responding to the objectives of the lesson. Type a question you might want to ask about this lesson. Thank you.